Hello and welcome to The Road to Net Zero, a podcast from the Advanced Propulsion Centre. So, what happens to an EV battery when it reaches the end of its life? Well, it's reborn. Our journalist David James visits Altilium Clean Technology, a battery material recycling company. It's supported by the APC with Automotive Transformation Fund feasibility study and scale-up validation grants, plus a new collaborative research and development project in partnership with Nissan. This is a longer version of an interview in David's video report, which if you haven't seen already is up on YouTube. Now, go check it out. Right, let's talk recycling.
One of the big criticisms you'll hear about electric vehicles is what are we going to do with all the end-of-life batteries? Aren't they going to be an environmental disaster waiting to happen, with millions ending up in landfill? Well, as Dr. Christian Marsden, the COO and founder of Altilium, explains in this episode of The Road to Net Zero, no. End-of-life batteries are a valuable strategic asset containing critical minerals that can be recycled over and over again to make new EV batteries. Christian explains that by 2040, 50% of all cathode active material needed for new EV batteries could come from recycling old ones. Eventually, there will be no need to open new mines, as almost all our demand for nickel, cobalt, lithium and manganese could be met by sustainable recycling. We went along to the Altilium laboratory in Tavistock and the new commercial-scale pilot plant in Plymouth, both supported by the APC, to find out more. So Christian, just tell us about Altilium as a company.
So Altilium is a clean technology company. We're supporting the UK's transition to net zero. We're focused on recycling end-of-life electric vehicle batteries to recover the critical minerals such as lithium, nickel, cobalt and manganese at a quality to rebuild new batteries. If we're going to get to net zero, what we need to do is electrify the grid and electrify the transport. And this requires large volumes of critical minerals, which the UK is not having large quantities of, and that supply chain is predominantly controlled by the Chinese. So what we're doing at Altilium is giving the UK a domestic, low carbon, sustainable source of critical minerals for an EV battery supply chain. What we are doing here in Devon is developing green processing technologies which allows us to recover those critical minerals. Our eco-cathode process allows us to recover over 95% of the lithium, nickel, cobalt and manganese almost indefinitely, forever. And we do that at a 60% lower carbon and a 20% lower cost compared to virgin raw material mining.
So what's the scale of the problem? There's several people who've got several problems here in this because it's a big supply chain. But from a UK automotive manufacturing point of view, what's the scale of the issue they're facing and how do you offer a solution?
So the UK, we've just registered earlier this year our 1 millionth electric vehicle. We have the largest second-hand car market in the Europe region. We have the second largest adoption of EVs outside of Germany. And also we have a gigafactory complex of battery manufacturing starting in the UK. When we talk about battery recycling, we have two streams of waste materials: gigafactory and end-of-life electric vehicle batteries. When a gigafactory is in startup stage, the scrap levels can be as high as 40%. When a gigafactory is producing in a standard way, the scrap levels could be as high as 10%. So there's a huge volume of scrap which efficiently and sustainably needs to be recycled and passed back to a gigafactory to build new batteries. If we talk around end-of-life electric vehicle batteries, what we see is a tsunami wave coming later this decade of end-of-life batteries, which all need recycled. They cannot go into toxic landfill.
So what's the current landscape at the moment? Because when I go to the household recycling, there's somewhere I can put lithium batteries and other batteries. What happens at the moment to scrap batteries?
Currently, the infrastructure which has been built in the UK is at the first step of battery recycling, which is essentially what we call production of black mass. So the black mass is the anode and the cathode waste from a battery, which is primarily from shredding the batteries or burning the batteries. So that material at the moment is exported to, for example, China. So what we expect in the future is materials which have the critical elements required for the energy transition won't be exported. They're almost a strategic asset of the UK. And what is required is companies such as Altilium to develop the technology and build the recycling refineries that from the black mass we can recover the lithium, the nickel, the cobalt and the manganese, and we can build new batteries to support the electrification of transport.
Now this is something that the critical minerals more broadly is getting a lot of government attention from governments around the world. I mean, Joe Biden and the White House are all over this and Europe. Just explain to those people that haven't been following critical minerals, just some of that macro landscape and why really there's a bit of a tailwind behind what you're doing.
So we could say that if EVs are just batteries, batteries are just minerals. So the energy transition for the UK requires large volumes of these minerals. One of the challenges is that these minerals are geographically concentrated in certain countries. So if we overlay that predominantly refining of these minerals is controlled by China. So if we look at the whole EV supply chain, it's very efficiently and very low cost managed by China. So we see that in the US we have the Inflation Reduction Act. Likewise, in the UK we have the Critical Minerals Policy, which is promoting a domestic supply chain of critical minerals, as well as a circular economy of critical minerals, where a recycling infrastructure in the UK will take end-of-life batteries, recover the lithium, nickel, cobalt, and manganese to put back into a supply chain to support the UK's energy transition.
Just explain some of the legislation that's around, because as I understand it, the manufacturers of vehicles start to become responsible for organising what's going to happen to their batteries, but also you can't keep buying virgin feedstock. There is a requirement to have recycled material in there. Just explain that to us a little bit more.
Yeah, we think at Altilium we have a number of regulatory tailwinds in this business. For example, in Europe, there is a recycling directive for end-of-life batteries, which focuses on minimum collection targets, minimum recycling efficiencies, as well as in the future, for example, in 21, new batteries will have to contain a percentage of recycled lithium, nickel, and cobalt. Essentially, automotive companies are being regulated to close the loop on a battery supply chain. What we see at Altilium in the future is a concept where there will be a green premium for recycled battery materials, possibly later this decade.
So what's the competitive landscape looking like? Because it sounds like this is going to happen. There has to be recycling, but you've got a first mover advantage, is that right?
Yeah. So we see that the UK is very unique in terms of it's an island. We don't see a scenario where end-of-life electric vehicle batteries will be put on ferries and transported to refineries in Europe. So this is a domestic industry which will be built in all countries actually. Wherever there is high volumes of EV uptake and gigafactory production, there needs to be battery recycling. Right now in the UK, Altilium is showing technical leadership in terms of the development of the hydrometallurgical refining technologies to recover the critical minerals from the black mass. And also, we're the only company which is scaling up to do battery recycling here. Our plans are for a plant in Teesside that would process battery waste from 150,000 EVs, and this will produce a battery-ready cathode active material, which 30,000 metric tons, which will supply circa 20% of the UK's requirement in 2030.
So something that I'm thinking about from an investor's point of view, you want to build a very large facility in Teesside. Large means high risk in a lot of ways. What have you done so far to de-risk the process? What steps have you taken to kind of give investors confidence that you can do this? Because Altilium is a very young company.
This is a new industry which is being built. What we're moving towards is mega-scale battery recycling in the northeast of England around a UK gigafactory complex of scrap. And that is the plan where we will be able to recycle battery waste from over 150,000 electric vehicles. So to control the quality of the feed into the refineries, as well as secure battery raw materials and be able to offer the full circularity model to our customers.
I don't know how much you can talk about, tell me what you can, but you have established relationships upstream and downstream. I don't know how much you can talk about, but just for those people that are thinking, well, where are you going to get it from? What's your market looking like? What can you say about that?
So we, for example, today are taking end-of-life electric vehicle batteries from a company called Synetic. Synetic is a first mover in the UK in having a circular economy around electric vehicle batteries which are coming into their scrap yards. So, we are taking scrap from there today for our scale-up programs. We've been very fortunate to have support from the APC, and we have one program, APC 23, which is with Nissan, and we have an open dialogue with them concerning the opportunities of battery recycling in the UK.
So this is a good moment. You've touched on the APC. Just talk about the support you've got and how fundamental it's been to your journey.
Yeah, so the APC has been transformational for Altilium, particularly the SURV program, which is focused on producing samples for qualification or commercial engagement with various stakeholders in an automotive supply chain. Basis that program, which ran 18 months, we were able to build the laboratory at our Act 1 site. We were able to produce battery grade nickel sulfate, cobalt sulfate, lithium carbonate, and we were able to show that to various different stakeholders and investors. As a result of that, we are now owned 11% by SQM Lithium Ventures, which is part of the SQM Group, which is one of the world's largest suppliers of sustainable lithium battery raw materials for electric vehicles. We were able to secure future funding from the APC and be able to engage with Nissan under the APC 23 program, which is currently running.
One of the big criticisms about the whole energy transition is what are we going to do with all these EV batteries? But you're saying you can just keep recycling it almost indefinitely. You just go round and round and round in a loop. You can keep using the same lithium, nickel, manganese, etc. So for those people that are still got in their head that electric vehicle batteries are an environmental disaster, how do you talk about that?
Firstly, the thesis of Altilium is to supply the critical minerals required for the energy transition and electric vehicles from recycling existing waste streams. By 2040, 50% of the lithium is no longer coming from mining. It's coming from battery recycling. So, of course, we need a lot of mining with good ESG between now and then. But essentially, once the volume of scrap products are in the system, we can very efficiently and sustainably recycle them to recover those critical minerals, to put them back into the supply chain. So, end-of-life batteries from electric vehicles aren't going into landfill because it makes no economic sense.
Is there anything else that we've not covered that you think is important?
When we talk around battery recycling at Altilium, we don't talk about recycling, but we talk about upcycling as well. So what we can do is we can take an 11-year-old Nissan Leaf EV battery, which is a older chemistry. It is an NMC 111 chemistry, which is 1 nickel. In our process, we can recover the critical minerals such as the nickel, but what we do is we re-engineer and we create a very modern new material. For example, NMC 811, which is 8 nickel. The nickel is giving the battery the density and the charging and the range. So that allows us to take a very old product and we can create a very modern material in a very sustainable way, very low carbon way, to pass back to a battery manufacturer to build new EV batteries. So we talk around recycling and we talk around upcycling old electric vehicle batteries.
Dr. Christian Marsden, thanks very much.
Yeah, thank you.
Thank you for listening to this episode of The Road to Net Zero. If you'd like to find out more about Altilium and their work on battery recycling, or how the APC are accelerating our progress to a low carbon future, visit apcuk.co.uk.
Thank you, David. And again, go check out the video case studies on our YouTube channel where you can get a peek into Altilium's facilities. Thanks once again for listening.